Hello friends. So we have a question having two parts A and B, and then there are some multiple subparts involving various concepts from permutation and combinations as well as cubic equations, drawing a graph and differentiation, etc. So let us try to start with the part A. It is given that there is a 3-digit code ABC. So we have a 3-digit code ABC where each of ABC can be assigned any of these values 1, 2, 3, 4, 5. We can assign any of these 5 values to this code ABC. In the first part, we have to identify the total number of possible codes. So we have 3 spaces to fill up, and there are 5 digits to use to fill up those 3 spaces. In the first part, it is said that any value can be repeated for any times. That is, even 444 is accepted, 121 is also accepted, or 123 is also accepted. So let us consider what are the number of options for filling up this first space. This first space can be filled up with 5 options. We can place 1, 2, 3, 4 or 5 here. Suppose let us consider we have placed 1 here. Now let us try to identify how many options do we have for the second space. As any value can be repeated, we again have 5 options, that is 1, 2, 3, 4 and 5. So for this space also we have 5 options. Now let us try to consider how many options do we have for the third space. As any value can be repeated, we again have 5 options for this space. So in total, we have 5 multiplied by 5 multiplied by 5, that is 5 cube, or 125 number of possible codes where any value can be repeated is allowed. Now let us try to consider the second part. In the second part, it is clearly written that no value is to be repeated. That means 1, 2, 3 is acceptable, but 1, 2, 2 is not acceptable. That the value cannot be repeated. Now again we have 3 spaces to fill. For the first space, we have suppose 5 options. Any one of these 5 value can come at the first space. Suppose we place 4 here. Now if we go to the second space, since the value is not to be repeated, the value which have come in the first space is not allowed to be placed on the second space. So now we have only 4 options to be filled for the second space. Suppose we place 2 here. Now we have already utilized 2 of these values, and for third space only 3 options are available. So the answer would be 5 multiplied by 4 multiplied by 3. This comes out to be 5 into 4, 20 into 3, 60. Or you can say that we choose 3 of these numbers and then we can rotate those 3 in 3 spaces, or this is same as 5p3, which is 5 into 4 into 3 equals to 60. Now let us move on to the part B. In the B part, now we have a cubic equation which is x cube plus ax square plus bx plus c. This is px, where a, b and c can be assigned any value of 1, 2, 3, 4, 5 as before, and we have to assume that no value is repeated. So it is very clearly written that no value is to be repeated. We are also given that px has factors. This is a cubic and it has factors which is x square plus 3x plus 2. This is an expression which can be factorized as x plus 2, x plus 1. This is a quadratic expression. We can factorize this as x plus 2, x plus 1. and it is given that these are the factors of this expression. So we know if these two are the factors, then p of minus 2 and p of minus 1 must be equals to 0. This is what the factor theorem states. Utilizing the factor theorem, we can say p of minus 2 and p of minus 1 must be 0. So in the first part, we have to identify the expression for b in terms of a. So we have two options here. First, p of minus 1 is 0. That means minus 1 to the cube plus a into minus 1 square b into minus 1 plus c equals to 0. That is minus 1 plus a minus b plus c equals to 0. That means c minus b plus a equals to 1. This is one equation we have. In the second part, we can also say p of minus 2 is 0. Why? Because p of minus 2 is 0 because x plus 2 is a factor. So putting this minus 2 the cube plus a into minus 2 his square plus b into minus 2 plus c equals to 0. This is minus 8 plus 4a minus 2b plus c equals to 0, or 4a minus 2b plus c equals to 8. So we have two equations, and how do we proceed forward? We have to identify the expression of b in terms of a. So in both of these equations, there is a common term which is c. So if we are able to remove c from using both the equations, we will be able to identify a relationship between a and b. So subtracting 1 minus 2, we get minus b plus a minus 4a plus 2b equals to 1 minus 8. So what we get is minus 3a plus b equals to minus 7, or b equals to 3a minus 7. So this is the relation between a and b. So we have identified the expression for b in terms of a. Now we have to show that the only way to assign the values is a equals to 4, b equals to 5 and c equals to 2. Now it is given that a, b, c can have only these values a, 4, 5. So in the question we have to prove that the only way the values can be assigned to a, b and c is only a particular manner. So how do we prove this? So let us try to assume that suppose we have a equals to 1. If a is equals to 1, b will have to be 3 into 1 minus 7, that is minus 4. But b cannot be minus 4 because there is no value which is minus 4 here. So we reject this. Now let us try to identify a equals to 2. For a equals to 2, this will be 3 into 2 minus 7, that is minus 1. Again, cannot have minus 1. Then a equals to 3. Suppose a is equals to 3, so b is 3 multiplied by 3 minus 7, that is 2. This is possible. So let us try to identify if a is 3, b is 2, then the only possible value for c left is rest of these values. So using the equation 1, that is c minus b plus a equals to 1, let us try to identify what will be the value of c. C minus 2 plus 3 equals to 1. So from here, what we get is c equals to 0. But now this is also not possible because c cannot be 0. So let us try to identify what happens when a is 4. When a is 4, this will be 3 into 4 minus 7. That is 3 into 4 is 12 minus 7, hence b is 5. And using this equation again, we try to identify the value of what can be the value of So this comes out to be C equals to 2. So yes, C can be 2, B can be 5, A can be 4. This is one of the possible solution because these all values are coming from 1, 2, 3, 4, 5. So now let us try to check A5. For A5, this comes out to be 3 multiplied by 5 minus 7. It is 15 minus 7 equals to 8, which is not possible because we do not have 8 here. So the only possible way is this, which if we see in the question is same. A equals to 4, B equals to 5 and C equals to 2. Now let us try to identify what do we have in the third part. In the third part of the question, it is given that we have to comment on identifying the factors of px. So do we have px here? Since A, B and C have been identified, the expression for px was x cube plus ax square plus bx plus c. X cube plus ax square plus bx plus c. And since we already know A, so this will be x cube plus 5x square plus, A is 5, so x cube plus 5x square plus B is, A is not 5. We have identified in the question A is 4x square plus 5x plus 2. So this is our cubic expression. We already know it has one factor as this. So we have to identify this another factor. This can be identified by division. We simply can divide this x cube plus 4x square plus 5x plus 2. If we write here x, so this will be x cube plus 3x square plus 2x minus minus. This is cancelled. This is x square plus x 3x plus 2. So plus 1. This is same as x square plus 3x plus 2. This is negative. So we are left with 0 remainder. Hence another will be x plus 1. So our cubic x cube plus 4x square plus 5x plus 2 can be factorized at x square plus 3x plus 2 multiplied by x plus 1, and this is also possible to factorize this term, which is x plus 2, x plus 1 multiplied. So these three are the linear factors for our given expression. So we are done with this part as also product of a linear factors. Now let's move on to the fourth. We have to sketch the graph of y equals to px. So y equals to px means y equals to x cube plus 4x square plus 5x plus 2. We have to sketch the graph. So let us try to understand this. These have three linear factors. So if we equate them to 0, we know that at x equals to minus 2 and at x equals to minus 1, the graph must cut our x-axis because y will be equals to 0. And when x is 0, the graph must pass through 2. Because when we put x equals to 0, the graph will pass through 2. And as x tends to positive infinity, the graph goes to positive infinity, and as x tends to minus infinity, the graph tends to minus infinity. So the graph must start from somewhere from the negative side. Somewhere from the negative side goes up. At x equals to minus 1, there are two roots, so it must touch at x equals to minus 1. And then at x equals to 0, the value has 2. It goes 2 and then it tends towards infinity. So this graph will have something like this. One root here and two roots here. So this is your graph. For more such questions, visit our website iitmacademy.com and register for detailed solutions and explanation. Thank you.